Hi there, hope you're okay. Let's have a look at this complex numbers question. So we are given a complex number, 18 root 3 minus 18i, and we're asked to write in the form r cos plus I sine theta. So if we want to calculate our value of r, remember it's just the square root of x squared plus y squared. X is your real part, y is your imaginary part. So that's going to be the square root of 18 root 3 squared plus 18 squared. And you work this out on your calculator, I'm sure I'll do it for you. This will give me 18 squared times 3 plus 18 squared. And then we'll factor out the 18 squared, that's 18 squared times 3 plus 1. So that is 18 squared times 4, which is then root 18 squared times root 4. So that is going to be 18 times 2, so 36. Again, you can just do it on a calculator, save you wasting time. So that's our value for r, and then to get our value for theta, it is inverse tan, arctan of y over x, imaginary part over real part, tan to the minus 1, so y is minus 18, and the real part is 18 root 3. So we need to do shift tan, and that is going to be minus 18 over 18 root 3. I could have cancelled the 18s, and I get minus pi over 6. And that's in between minus pi and pi. So 18 root 3 minus 18i is equal to 36 times cos minus pi over 6 plus I sine minus pi over 6. And you could obviously write it, you could put a minus I or something, but just to keep it consistent with that, I'm not going to. And then for part B, we're asked to solve this equation, z to the 4 equals the complex number that we've just converted. And it wants them in the r e to the I theta form. So I'm going to convert this into that because it's way better. So this is 36 e to the I, or minus I pi over 6. We do need to remember that we're going to get different values because the period of the exponential function is it's 2 and pi. Well, the period is 2 pi, so we can have 2n pi onto our argument. So we are trying to solve z to the 4 is equal to 36 times e to the minus I, I minus pi over 6 plus 2n pi. Where n is going to be an integer, obviously, and this is just our argument for going beyond. So we've got z to the power 4, we're going to divide the index by 4, so to keep it in that range. So if I want to work out z, well, I need to take the 4th root, so for that'll be plus or minus 2 for that bit, and then it's going to be e to the I, and then all of this stuff, minus pi over 6 plus 2n pi over 4, because that's how indices work. So it might be worth, this particular part here, let's work out the range of values it could be. So this needs to be in the region between minus pi and plus pi, it's inclusive at the top end, yep. So one way of actually doing that is actually solving a little equation. So 2n pi over 4. So we know that that has to be in the region between minus pi and plus pi. So if I multiply that by 4, I'm going to get that this has to be in the region between minus 4 pi and positive 4 pi. If I add pi over 6, 2n pi is going to belong to the interval minus 4 plus 1 over 6 is minus 23 pi over 6. And I need to do the same but with positive 4, so that's 25 pi over 6. And then I can divide by 2n pi to work out what my n's got to be. So divide by 2 pi, sorry. So if we get 23 over 6 and then divide that by 2, so we've got 12 on the bottom. That is minus 1.91. And then if I do the same thing with 25, that is 2.083. So that tells me my values for n are going to be -1, 0, 1, and 2, because it has to be intervals. Sorry, it has to be integers in that interval. So we've got our formula for our complex number that's going to satisfy the equation there. So let's just put a label on the different ones. So z when n is -1 is going to be plus or minus. Sorry, I don't know where I got 2 from there. So square root of 36 is 6, and then I square root that again, so that's root 6. So that's plus or minus root 6 e to the I, and then we're going to put in -1 into this bit at the top for our argument. So I'm going to write minus pi over 6 plus 2 lots of, in this case being -1, and then we're going to get pi again. And then the whole thing is going to have to be divided by 4. So that gives me minus 13 over 24 pi. So my calculator's got a weird way of writing it. So e to minus 13 over 24. And then I just need to go back and change the -1 to a 0. And that gives me minus pi over 24. So z when n was equal to 0 is plus or minus root 6 e to the minus I, and that's pi over 24. I think I missed off pi here, so put that back on. And then I add n equals equal to 1. So z when n was equal to 1 is plus or minus root 6 e to the minus I, and that's 11 pi over 24. And then z when n was equal to 2 is going to give me plus or minus root 6 e to the minus I, and that's 23 pi over 24. So there are my 4 roots. In terms of plus or minus, I can actually get rid of these, although you would normally include them, because that is a factor of e to the minus I pi, or -1 out. So that's essentially the positive and the negative. And same with this, that's essentially e to the minus I pi out, which remember is -1. So again, they're the positive and negative roots. So they are all my roots that I need for this question. I've got fractions where the numerator is less than the denominator, so our argument is in that form.